Welcome back to the online class of Al-Faruq School, Padaparamba. We are discussing the first chapter, real numbers. Today we have to discuss about the revisiting rational numbers and their decimal expansion. As you know that the decimal expansion of a rational number is either in the form of terminating or non-terminating repeating. Okay, so we have to take two conditions. First condition is that rational number p by q terminates if the prime factorization of the denominator, that is q, is of the form 2 raised to m 5 raised to n. That is the first condition. Second condition, that is rational number p by q not terminate repeating if the prime factorization of the denominator, that is q, is not of the form 2 raised to m 5 raised to n. These are the two conditions. Once again I am repeating. The decimal expansion of p by q is terminating if the prime factorization of the denominator is of the form 2 raised to m 5 raised to n, which means includes only 2 and 5. And the second condition is that the prime factorization of p by q is not of the form 2 raised to m 5 raised to n, that is which includes any other numbers other than 2 and 5, then that decimal expansion non-terminating and repeating. Okay, let us go through some examples. Okay, consider a question. Without actually performing the long division, state whether the following rational numbers have terminating or non-terminating repeating decimal expansion. Question number 1. 18 by 50. We have to check whether the rational number is terminating or non-terminating repeating without actually performing the long division. For that, we have to find out the prime factorization of the denominator. In the first question, the denominator is 50. Let us find out the prime factorization of 50. 5 2 25 by 5. So the prime factorization of the denominator 50 can be written as 50 equal to 2 into 5 square. Look at the prime factorization, which includes only 2's and 5's. So we can conclude that it is a decimal expansion that should be terminating, because it is a prime factorization is of the form 2 raised to m 5 raised to n. So it is terminating. Clear? Now let us consider the second one. 17 by 24. Here the prime factorization of 24. We have to find out the prime factorization of 24. By 2, 12, by 2, 6, by 2, 3. So the prime factorization of 24 can be written as 2 cube into 3. Now look at the primes. Here 2s and 3s. Here a new number 3 is coming. So is the prime factorization is non-terminating repeating. Once again, is the prime factorization is not of the form 2 raised to m, 5 raised to n. We can say that is the decimal expansion is non-terminating repeating. Is it clear? Now let's find out the last one. 13 by 3125. Let's find out the prime factorization of the denominator, that is 3125. Divide by 5, 31, 6, 12, 2, 25, 5. Again by 5, 6, 1, 12, 2, 25, 5. Again by 5, 12, 2. Again by 5. So the prime factorization is 31 to 5 equal to 5 raised to 5. So which includes only 5s. Okay. So we can say that it is of the form 2 raised to m, 5 raised to n. Why? This can be written as 5 raised to 5 into 2 raised to 0. Okay. So which includes only 5s and 2. No other numbers except 2 and 5. So it is a prime factorization is terminating. So once again I am repeating in Malayalam. ഒരു ഡെസിമൽ എക്സ്പാൻഷൻ ടെർമിനേറ്റിംഗ് ആണോ എന്ന് പറയണമെങ്കിൽ അതിൻ്റെ ഡിനോമിനേറ്ററിൻ്റെ പ്രൈം ഫാക്ടറൈസ് ചെയ്ത് കഴിഞ്ഞാൽ അതിൽ 2, 5 എന്നീ രണ്ട് നമ്പേഴ്സ് മാത്രമേ ഉണ്ടാകൂ. ഈ രണ്ട് നമ്പേഴ്സ് അല്ലാതെ ഏതെങ്കിലും മറ്റൊരു നമ്പർ ആ പ്രൈം ഫാക്ടറൈസേഷൻ ഉണ്ടെങ്കിൽ we have to conclude that the decimal expansion of that rational number is non-terminating repeating. Okay, that's all from today's class. Before winding up, I would like to give you some homework in your textbook. Okay, please note the page number and the question. Homework, page number 17, exercise 1.4, question number 1 now. To 10. So once again I am repeating the homework. Your textbook, page number 17, exercise 1.4, question number 1, 3 to 10. 3 to 10, 80 questions. Okay, that is all from today's class. I wish you a very nice day. Thank you.